All right, I think we'll go ahead and get started. For those of you who haven't seen on the list, my name is Bryan Hughes. I work at Rdio, where I mostly do front-end work, and today I'm going to talk about ECMAScript 6. Specifically, I'm going to talk about some stuff that, smaller little details that haven't really been getting a lot of focus. Hopefully you've all heard about modules, classes. All right, can you hear me better? All right, thanks. And so, hopefully you've all heard about classes and modules. These are coming. Generators are going to be really cool. We heard about them some in the earlier talk today on ECMAScript 7. We're also getting promises. But I'm going to talk about the other stuff, that you may not have heard about. So starting off, I'm going to talk about block-scoped variables. This is going to form the basis of everything else in the talk, so just want to make sure everyone's aware of them. We're getting a new replacement for the var keyword. And with this, we're actually going to get properly scoped variables. They'll work the same way they do in Java and C++ and all these other languages. In JavaScript today, as you probably know, if you use the var keyword, this actually gets hoisted to the top of a function. So if you have your variable inside of a for loop or an if statement or something, you can access it outside of that for loop or if statement. You can even access it before the for loop or if statement. Whereas now we're going to get two new keywords called let and const that work just like variables do in Java or C++ or something like that, where you'll actually get an error if you try and access it before you declare it or before or if it's outside the block, as we can see here. So I've created two variables. We have foo, which is an actual variable, and then we have const bar, which is an actual constant. If we try to modify the value of bar, it will actually throw an exception. And if we try to do access foo outside that block, we also get an error. So that's pretty cool. Next up is template literals. We're actually getting native string templating inside of JavaScript itself. So this is similar to templating in PHP and some of those. And sorry, handlebars. And it basically looks like this. Here we use the backtick character to signify that this is a template string, not just a regular string. And with that, you can then do the $ followed by 2 curly braces. And whatever is inside of that will be evaluated as JavaScript. So in this example, we create a variable foo. We give it the value of bar. And then we inject that into the string. And of course, we get hello bar. Oh, that is actually a typo. My mistake. Yeah, so we actually should have a closing bracket after foo instead of a parentheses. That was probably my editor trying to autocomplete on me. So next up, I'm going to talk about computed property names. So this is a new way of creating a key in an object literal or a class literal. So as you know, in an object literal, you can give it just the name of the variable. You can just say foo : and then you have your value. Or you can have a string. You could do quote foo quote : Well, this is a new way, and it's actually pretty different. What it allows us to do is take the value of a variable and use that as the key name. And it looks like this. You use the square brackets for the left-hand side on your property, and we'll take whatever the value of that expression is and use it as a key. This is just like if we had done, let my object equal, 2 curly braces, and then on the next line, we did my object bracket, my prop in bracket equals something else.
We can use this instruction only with the let keyword or with the simple var.
You can use it with simple var as well. And in fact, this can be any expression you want. So you could have, say, my prop plus 1. You could even throw that, well, not in this case, you can't throw in a loop, but you can use like iterations, you can call functions, it's any JavaScript expression you want. That's not a statement, so you can't say, return, obviously.
What's this called?
This is called computed property names. And these slides will all be available online, so don't worry about trying to type down every last little detail. So next up is a new property shorthand in object literals. A lot of times, we'll end up typing something. We'll create a couple of variables, and then we sort of wrap those variables up into an object. And we usually end up with something that looks like bracket x colon x, y colon y. And we'd end up repeating these over and over. And so this is a new little shorthand that allows us to just collapse those into a single thing, x. And it looks just like this. So we create two variables, x and y. Then we say let my object equal, curly brace x comma y. You notice there's no colons or anything in this. And what it does is it will create a key or a property with the key of x and give it the value of the variable x. And so in this case, we have x and y equals 1. And if we log out the keys of this, indeed, we see x and y are the keys of this object. And we actually get 1 and 2 back for their value. So next up is a method shorthand for object literals. There's been a lot of work in object literals, as you can tell. This one is probably my favorite. This is the one I use all the time. It really gets rid of a lot of the boilerplate for including a function inside of an object or a class. And with this, what we do is we actually drop the function keyword and we drop the semicolon, and we just simply give it the name of the function, followed by parentheses, and whatever arguments you would give it, followed by the function body, curly braces in this case. So if we do myObject.foo, indeed it will call this as a function and call it a bar. And I use this all the time in a lot of my personal projects. I'll be using like ES6 on the front end plus React and Flux. I've been doing a lot of that lately. And I'll have Node.js and Express on the back end. So I'll be writing all this code on the front. I'll go to Node.js and I'll type in foo parentheses bracket. And I'm like, wait, why is Node complaining at me? Right, because it doesn't have ECMAScript 6 yet. So once you get used, I found that once you get used to this one, you use it everywhere.
What about those browsers?
Currently, I don't think any browsers support this natively. I could be wrong. Chrome maybe. I haven't tested recently, but I use Tracer for everything.
Only for Node.js?
Node.js does not support this either. I don't think any engines do. But Tracer, which is a compiler, that will basically compile your ECMAScript 6 code back to ECMAScript 5, supports all of this. And that's what I tend to use a lot in my projects. Traceur, Traceur. It's from Google.
This would also be inline, so we have to move.
Yes, correct. And so next up is symbols. This is another way of kind of creating our object literals or our classes. So symbols are a way of doing actual private methods in JavaScript. So this is something we've never had before. And it's really, really handy. Typically today, if you want a private variable, well, typically we just prefix it with an underscore and then move on. But of course, that's not private. Anyone can call it. And we've all done those hacks where we got to get at something, so we just call it, which is not a good thing to do, but we do it. So this is an actual private method or private property. Now it's in its own JavaScript way. We had to make it work with the language, so we don't use the private keyword. It looks different than the other languages. What we do instead is we create a new instance of this thing called a symbol. And we actually do let foo equal symbol, and then we use that to define our properties. So in this case, we create an object, then we use foo, in the brackets as a value, and we set equal to bar. Now, one thing about symbol is symbols cannot be converted to strings. And if you try to access this with a string, if you said my object.foo or my object, bracket quote foo, that actually doesn't work. You can't get at it that way. So unless you have a reference to this variable, you can't get at it. And as we can see, in this case where we actually called it here. I'm sorry, say that again? No, it does not show up in object.keys. And it's even more private than if you had defined your property using object.defineProperty and passed in a numerable false. This is another trick people will do sometimes, but you can actually still get at it if you just happen to know the name, or say you look at the source code. You can still get to it. Whereas with symbols, you can't get to it no matter what. Exactly.
Normal people don't.
Right. Right. That's one of those things where no one can get to it. Even the hackers. Now, there's some cool stuff you can do once you start mixing these things together. So like symbols are kind of cool, but on their own, whatever. And same thing with computer property names. When you mix those two together, you get some really, really nice looking code. So what we can do is we can create a class here, and we create a symbol, and then we put that into a computed property name, and that is actually a private method. So this is how we get our nice syntactic. It's almost like doing a private class in Java or C++ where it's nice and inline in your function definition. And of course, once again, private, can't get to it, so it's great.
Can you put this single constructor just in the expression in the square brackets?
You can. If you do that, no one can ever get to it, though. Because to reference it later, you have to have a reference back to your symbol. So I always like to put it just right outside at the very top of my class, and, kind of like in a couple of lines before. Of course, it's up to you, whatever style you want to. But this is the style I like to do, is right before your definition.
So in this case, the key
Mm-hmm.
would be anything including the class hierarchy?
Mm-hmm. Oh, that's correct. Well, yeah, I mean, you can use it at any level of inheritance. Are you referring to multiple levels of inheritance? Yes, you can use it up and down as long as they have access to it. But of course, let's say you create a base class in one file, and you have symbols in there, and you have another class in another file. In order for that other class to get to it, you still have to pass a reference to that symbol along somehow. And if you are exposing that on your interface, then, well, it's no longer private, and you kind of defeated the point. So yeah, this is like true private. This is not like protected, say, or like friend properties in C++ or some of the others. So next up is fat arrow functions. You might have seen these a little bit throughout the day. This is a new way of creating functions or specifying functions. It's a shorthand, so you save code. But one of the things I really like about it is that we actually get sane this bindings. And, how many times have we all been writing JavaScript code? We have a method on a class somewhere. We call it, it ends up crashing because it turns out this is window, or global if you're in Node.js land. As careful as we are with our code, sometimes you still run into these issues. Well, fat arrow functions have totally different rules for how the this binding works. To back up a little bit, in case you aren't familiar with the exact rules on this in JavaScript, they're actually pretty simple. They're just different. The this value is determined by how a method is called. It has nothing to do with if it's part of an object or a class or anything like that. So if you do something dot something, whatever that first something is before the dot, that gets set as a this value. But of course, if you alias that, let's say you're calling this method over and over, so you say, well, I want to assign it to a var. So you do var foo equals bar.foo. And then you call foo. Well, that actually messed up the this binding. Whereas with fat arrow functions, the this will always be the outer scope no matter what happens. And so as an example, here we have an object. It has a property on it, foo, something we can access. And then we have our method print. And in this, I'm doing a self-calling function, which normally if you do a self-calling function, your this value is window. And to get around that, you'd have to then call like bind or something like that. Or you might do a var self equals this, or some sort of a workaround to get to this binding you actually wanted. Whereas in this case, it actually works exactly like we'd expect. You can see we call this.foo on the inside. On the output, we actually get bar the way we want. So they're very, very handy. In addition to being more concise, we get a great this binding to it. I use these all the time as well in my code. So next up, I'm going to talk about REST parameters. So REST parameters is a replacement for the arguments keyword. The arguments keyword, for those of you who don't know, inside of a function, you can reference this keyword and you get all of the arguments passed into the function. But there's a lot of problems to it. The biggest one being that it looks like an array. You access it with indexers 0, 1, 2, 3, but it's not actually an array. So you can't do certain things like concatenating with it with other arrays. You can't do like slice or a lot of those things. So what you often have to do is you have to coerce it to array, and there's some kind of funky ways of doing that. So REST parameters completely deprecate arguments, and they actually give us some other cool stuff too. So the way you define REST parameters is you have your function. You have a couple of arguments. These are just regular arguments, A and B in this case. And then the very last one, and this does have to be the last one, you have 3 dots, or 3 periods, and then your symbol name, in this case REST. And what this says is take whatever arguments are left over after those first arguments A and B, and just wrap them up into an array. And this is an actual array. You can see here we're doing array.isArray. This will return true. Whereas with arguments, of course, this will return false, and then you run into all your issues. But it's also really nice because you can have these parameters at the very start of it. You can have A and B, And REST does not include A and B. So if you want to have something with an argument or with a signature like, say, call or apply on a function, where the first argument has like some value, and then you have a list of things, but that list is totally unrelated to that first argument. This way you don't have to like slice it out or pop it off or things like you would do with arguments. So that's really cool. If we call this with 1, 2, 3, 4, 5, as in the example, A and B get the value 1 and 2, and then the variable rest gets the array 3, 4, 5. And you can call rest whatever you want. It could be, more extras, whatever. I just chose rest. It's the ... that signifies rest parameters. Now, of course, rest parameters, they actually have a cousin called spread parameters. And this is essentially the inverse. So rest parameters take remaining arguments and squish them into an array. You can use the spread operator to take an array of things and sort of spread it out for the arguments of your function. So let's say we have a function that takes 4 arguments, as in this case. We can create an array that has these values in it, and we can call that function with first just some regular prop, and then we'll spread out that array for the rest. And so when we call it like this, we actually get 1, 2, 3, 4. So this is a really great replacement for, say, call.apply. A lot of times when we use, function.apply, whenever we have a function and we use the apply on it, you give it a this binding and then an array of arguments. I feel like a lot of times when I do that, and I think most people are the same, we don't care about the this binding. We care about the fact that we can take an array and turn that into the arguments. And so we end up repeating the this parameter. Sometimes we get it wrong, and then that's a bug in our code. And so with this, I think this will replace a lot of use cases of function.apply. Next up is the for-of statement. So the for-of statement is a new way of iterating over arrays. This is the kind of thing that I think a lot of people expect JavaScript to have, especially when they see a for-in loop. And for-in doesn't work the way people expect. For-of works the way we think it would expect. And so this gives us really good iteration of arrays, except when it doesn't do the things we want it to do, of course. And so that looks like this. We use the of keywords. So we have an array. We say for let my element. This is what each iteration that value is going to be put into. And it'll take the value of each element in the array and pass that into the loop. So if we log this out, we can see we get A, B, and C. And so it's equivalent essentially to doing a for each. You do myArray.forEach, or if you're in underscore land, underscore.each, except that we don't have to use a separate function to do the iteration. So it's much, much more performant than doing for each. Next up is the structuring. Sorry, yes? Mm-hmm. Yes, it does. Well, it enumerates the same way that it does typically. So if it's an object, you're not guaranteed order. But if it's an array, you're guaranteed order of indices.
Okay. When does it work like you expect? You mentioned that before.
Well, if you need the index, it doesn't work. And so like one thing in for each, you can actually get the index out as well as the key. And so it's not a replacement for each in all cases. If you need the index to do some operation on, say you're going to delete an element or something, you can't use for-of.
Does it work with the objects?
Yes, it works with plain objects as well. I think that's less useful because you only get the values. You don't know what key was associated with it, but it does still work.
It will work the same as for in loop, or it will go through the prototype chain.
Yes, it does. It does.
So it's useful for the areas of the code.
Yes. So next up, just structuring arrays. This is kind of one of my favorites. It's just a really neat little thing. For those of you who've used Python, you're probably familiar with tuples. And one of the things that I love about Python is you can return multiple values in the form from a method in the form of a tuple. Whereas in JavaScript, if we want to return multiple values, we usually have to return an object. And then, so we'll essentially take these values, bundle them up into an object, return that. And the first thing we have to do then, of course, is assign that to a temporary variable, then alias out all the properties to other variables and go on and use it. So it's a lot of extra work. And structuring arrays is essentially a shorthand to get around that. And it works just like returning a tuple in Python, because you can do the same thing. So we create an array. We give it, in this case, 2 values. And then what we do is we say let. And on the left-hand side of our assignment, we actually have this thing that looks like an array. We use the square brackets. And we have these 2 identifiers. And this is actually saying we're going to create 2 variables, of names A and B, and we're going to assign to them the first and second value from the array, index 0 and index 1.
Same as least to PHP.
Yes, it is. And so when we log these out, we indeed get 1 and 2. So pretty handy. But they actually took it a step further. Yes?
Sorry, I have to go back one slide. So what if I change my array after I assign A and B to it? Do they just point to it, or do they actually hold the value?
They hold their initial value. So yeah, if you change the array afterwards, let's say we then say my array 1 equals 3, B will still be 2. Now, we can actually do the same things with objects. And this is where I think this gets really powerful, because I haven't quite seen anything like this in the mainstream languages. And that basically looks like this. So we can create an object. We have a couple of properties, a couple of values on it. And then we can say let, and on the left-hand side, we have this thing that looks like an object. We give it the name of the property we want to reference on the left-hand side, and what would be like a key. We say 1. And on the right-hand side, we say of this key value pair looking thing, we give the name of the variable we want to assign it to. So what this will do is it will create two variables, A and B. And in A, it will assign myObject.1, and B, myObject.2. If any of you are language nerds, this is basically kind of a primitive form of pattern matching, which is a very, very powerful concept, but none of the mainstream languages really do it. But it's still really, really handy, because we can easily then log out A and B. I find this is really useful for dealing with, like, say, XHR requests, or you get your REST call back, and that's an object, and the first thing you assign that to a temporary variable, then you parse out everything else. So this makes that logic quite a bit cleaner. So I'm kind of a personal fan of this one.
Maybe it's just me, but it just tends to me like the A and the 1 should be the way.
That was my thoughts too when I first saw it. The reason that they put the key first and the variable second is essentially you're trying to replicate the look of it.
I think the key is
Well, the key is not A. A is a variable that you're assigning to. You're pulling the key of 1 from my object and assigning that to A. So it's it makes it look the same, but I think it's one of those things that we just have to get used to.
Can you just destructure a part of the object?
Yes, you can destructure just a part of it. And you can, let's say we have my object 1 and 2, but we just want to get 1 from it. We could easily leave off the second part. So that, they do not have to match at all. And if you include extra properties, let's say in the let statement I had 1, 2, comma 3, colon C, C would simply be undefined. So there's a lot of these great little things involved. I think the real power in a lot of these new features comes when you start using all of them together, though. I mean, it really is a case of the whole being greater than the sum of its parts. So here's an example. It's a contrived example, but it's an example that kind of brings most of these things together. So we start off by creating a couple of variables, A and B, and we use those as computed properties in this little kind of listy thing here. We have this function print that takes in a variable number of arguments. So we're passing in 2 objects to it. This is not an array. It's just flat 2 arguments with these computed properties A and B from methods. And inside that we have this templated string. And then what this essentially does is it will print out a first and last name from this object, but it can also control capitalization at the same time. You can see in a more practical example using this kind of thing to do, say, internationalization and localization, things of that nature. So inside of this method, we're using a REST parameter, so we're spreading it out. And we're iterating over that using a for of. And we're printing everything out, so we get a last name, comma, first name, lowercase and upper, just mixing it up. And we actually see some pretty cool stuff. So it's pretty small. It's a contrived example, sure, but it's showing it all together. Now, this is 340 characters. I counted that up. The reason I say that is, of course, we want to look at what this will look like in ES5 today. In fact, if you use Tracer, it'll give you an output that looks pretty much exactly like this. And the output is that. So you can immediately tell it's longer. If you know the exact details, this is 570 characters. So it's just a little under twice as long. It's a lot more verbose, but it's also a lot denser too. There's some things if you start digging into it, like for example, if we look at the top of the print function, you can see we're doing some funky things here to coerce arguments into an array. And if you want to figure out how that works, you've got to know how apply works, you got to know how slice works. you kind of have to understand what's going on with the this pointer whenever you pass in. You're mixing this pointer types. We're passing in a non-array thing as a this pointer for an array call. So you have to know how that works, which means dig into the spec. And it's kind of complicated. We're using for each, which it's a little more wordy. But in addition, as I said earlier, it's not nearly as performant either because we're doing a separate function call for each item. And in general, the whole thing's just not very readable. So with ECMAScript 6, we get all these nice little things. We can start writing more concise code. In a number of cases, it will be more performant. And it's more readable. So we actually get wins all around. We don't have a lot of the typical trade-offs we tend to typically have when deciding between terseness and shortness of code, readability, and performance. And with that, are there any other questions? So the question is Tracer the best transpiler for ES6? I think so, at least right now. Now, it is a general purpose transpiler. It works generically with ES6 code. Sometimes you can do a targeted compilation. I heard a talk from Facebook a few months ago, and they were doing something like this. So Facebook uses a lot of ECMAScript 6 in their code. All of their React and Flux stuff is written in ECMAScript 6. My understanding is they have a custom transpiler, though. And the reason they did that is they had an existing framework that had its own conventions and stuff, and they were able to compile it back to that. And knowing that they were only using certain subsets in certain ways, they were actually able to come up with a more efficient output target, more readable, more efficient ES5. And that just comes from being able to do a very domain-specific type of transpilation. But I use Tracer. I think it works well. You do have to be careful with Tracer. There's a few areas that are not very performant. So like if you use the let keyword, you can actually get in trouble. Because of the way let works, the way they implement it is kind of ugly. They actually do a try-catch where they throw undefined inside of the try. So they're always throwing, and then they catch it because if in try-catches, catches create their own scope. And that's how you get like the proper scoping and stuff. But as you also may or may not know, try-catch is not very performant. You're having to create this new context, and that's known to be expensive in JavaScript. So if you use let, you take performance hit, which may not be obvious at first. And there's a few other things kind of like that you had to know about Tracer.
I noticed you using let all over the place.
Mm-hmm.
Why would you use let in like the global scope? Isn't it no different than var?
The only so the difference between using let in the global scope versus var is that let is not hoisted. But other than that, it's the same. So in most cases, you won't see a difference.
Can you reuse let again? Can you get a compiler?
So can you redefine variables? It depends. If I remember correctly, it depends on if you're in strict mode or not. Just like in strict mode, if you redefine a variable, I think you get an exception. But if it's not in strict mode, you don't, if I remember correctly. I never redefine my variables, so I can't say I run into that issue. Now, I will say if you do let inside of two separate blocks, let's say you have one if statement followed by a separate one, and you let inside both of those, then that's actually not an error ever because they're both scoped to just their own separate if statements. Is there any reason to ever use var again? No. Totally deprecate. Once we have actual support in browsers, that is, no reason to use var again.
Is all that stuff definitely happening, or is any of it just proposed?
So all of the stuff you've seen today is definitely happening. So at this point, the ECMAScript 6 specification is pretty much nailed down. There's still some flux on the module spec. And then there's like lots of little details around edge cases for everything. But the basic spec is completely nailed down. And in fact, all the code snippets I shot, you can go to this code link and download from there. And there's an example at that link that will actually run in the browser using Tracer and actually does work today. And all of the stuff that works, the way I showed it, will work in browsers that way. It's mostly just edge cases, like really funky things if you're doing crazy call applies and weird iterators on things you're not supposed to iterate over. Those are still a little bit up in the air. Any other questions? All right, thank you very much.